So we want to solve these exponential equations, and we're going to solve them just like linear ones, but we'll have to use a little bit of log or some of our mental math. So first so let's look at this first one. We have a 4 times 10 to the power, so we're going to divide by 4 on both sides. The opposite operation, so we'll be left with 10 to the 2x minus 1 equals 1,000. Now right here, from our math experiences and maybe a little bit of your review in class, we know that like 10 squared is 100, or 10 to the third is 1,000. So thinking of that, if we know 10 to some power needs to be 1,000, we know this power right here needs to be 3. So we could just solve that. 2x minus 1 better be 3. If you add 1, you get 2x equals 4, and divide by 2, we know that x is going to be 2. And if we put that back in here, 2 times 2 is 4, 4 minus 1 is 3, 10 to the third is 1,000, times 4 would be 4,000. But since we're working with these logs and we start solving them using logarithms, when you take the log of both sides, logging, I say, is for bring things out of trees. And since our power is in the tree, we go logging. And so that would make my power come down. And technically, I would have log of 10 here equals log of 1,000. We should know these from our previous math classes. When you log 1,000, you can write on your calculator, that means 10 to what power is 1,000? Well, that's 3. 10 to what power is 10? That's 1. Now you don't have to write the 1. I won't in future times here. But there we have 2x minus 1 times 1. So since that's essentially gone, now I'm going to add 1 to both sides, and I get 2x equals 4. Should look familiar here. Divide by 2, I get x equals 2. Let's try another one over here. These ones won't be so pretty. We can't do so much mental guessing. I'm going to divide both sides by 1.7. And that would give me 570. So I have 10 to the 3x plus 1 equals 570.588. Now I'm going to get that power out here. So again, since my power that I want to solve for is in the tree, I'm going to go logging. So log both sides. Now this certainly isn't going to be pretty, but I'll have log of 570.588. Try not to round decimals too early. Technically, this could be written as log of 970 or 1.7 if we're getting exact. So be careful. If you don't want to round decimals, you could leave it like that. Now the log and the 10 will cancel, and that's because up here, remember, log 10 made 1. All we're left with is our 3x plus 1 equals there. So to get I will log 570 here. I get this side to be approximately 2.7563 equals 3x plus 1. Now I'll continue solving like linear equation. Subtract 1 both sides. 3x equals 1.7563, and then divide by 3. Get x to be approximately 0.585. And if you ever check, this decimal isn't going to be perfect, but you could always plug that value back in up here to your equation, and it should come out to about 970. All right, let's try this last one real quick here. See if I can switch it in. We have to divide by -2 on both sides. So that means 10 to some power makes -150. Well, if I go logging, I have that power in the exponent. So if I log this side, the x will come down. I have to log this side. I dare you to log a -150 on your calculator. It ain't going to happen. That's technically our answer. And think about this. If you've looked at the graph of log of x, let me show you here. Sorry. If we look at the graph of log x, apparently I don't have it on here. Sorry to move my time. But the graph of log x never goes into the negative region. So graph that for yourself. Sorry, I thought I had it here. But you're going to find that you cannot log a negative number. Good gravy. Sorry, guys. You cannot log a negative number. Therefore, there is no solution on here. And that's because log never has negative answers.